So these fibers, it is the fibers that actually do the work. What does the work? What do we feed in our body? Why do we eat? What are we feeding? We're feeding the cells, right? So the fibers are comprised of cell bodies that are hooked together to make long fibers. So the cell in our body is what does the work. The heart pumps, but only because the heart muscle contracts. So when we think about how muscles work, we got to think about how these fibers react to changes to make them contract. First of all, we have individual little segments that make up a fiber. So fiber is not just big one long thing like this. It is a bunch of small things that are hooked together to make a fiber. Okay, if you look at your hair, it's just small things hooked together to make a hair. That's why it breaks and does stupid things, splits, okay? Smokes when you put the heating iron to it. So we have these little things that are held together by this way, but nothing holds them together this way. So we have to cover them up with a sarcolemma or another sheath, like we did the saran wrap. So we have to put each one of these in a type of saran wrap to hold these little guys in their line. Fiesta, Texas. When you go to a ride, do they just have a big open area and everybody knows that they stand in line this way? No, they have you corralled in there, don't they? You can't really go either side because you're corralled in. And that contains the crowd and keeps it going the way it's supposed to. These little guys would do whatever they wanted to, except we have to contain them with a sarcolemma, a wrap around them. All right, so here's my sarcolemma, the purple, around the little segments. Each segment is a type of cell. Okay, has its own little nucleus. Along the way, this membrane sinks into toward the middle of the fiber. It's kind of like, here's the sarcolemma, and you tighten it up, and it kind of sinks in. Okay, so we go along, it sinks in. It comes back out, it sinks in, it goes back out. Called the T-tube or the transverse tubule. Now, what's a tubule? Is it hollow or is it solid? It's hollow. That means it must carry something, huh? Tubules carry something? Okay, so we got to think about this. That means these little cells right here called myofibrils have to get something. So the tube goes in to deliver whatever is needed. Just like we have a tubule called an esophagus that delivers what we need. So the myofibrils, myomuscle fiber, are these little individual units that make up a fiber of muscle. Or if you stand up there, please. You too. You're friendly. Come on, Claudia. Okay, come on up here. I don't want to see your butts. Right now, they are considered myofibrils. Right? They're individual little cells. They're not connected. And if I told them to move, which way do they go? One would go this way, one would go that way, one would go this way, right? But is that the way a muscle contracts? No. We lose all strength if they go different directions. They have to work as a unit. So, Mr. Edgar, kind of cup your arms. There you go. Taking us since Valentine's Day. There you go. Okay. Now, the fibrils, the myofibrils, have connected together, so now they're more of a unit, but they can still go wah, wah, like they're doing. But if I put some duct tape around them now, the only thing they could do is go where I tell them to go. Do you agree with that? You know, this one can't step out, that one can't step forward. They got to do it one direction. I don't want you going this way. I don't want you going back. You just kind of go back. You come up. I don't want, what kind of contraction is that? Is that pulling on anything? No, it's not doing a dang thing. But if I keep them confined this way, so the only way they can go is either that way or this way, then they can contract and do what? Move something. I'm a bone. Move me. Okay? So we move. And when they relax, the other muscle underneath's got to pull us back this way, correct? But they're going that way. If I said move, one went this way, one went this way, would we move anything? No. Okay, thank you. Myofibrils. So each one of them was a part of the fiber, but they all have to act the same way, so we have to confine them with a sarcolemma. Hold them together. We have to be able to feed them or get them the stuff they need to make them contract. So we have these T-tubes that go in to feed the center of that cell or that fiber and cause it to contract. A sarcomere, okay, the sarcomere up here is also a unit that we find in there. It is the contractile unit. So even I'm calling you a myofibril, a fiber, okay, the contractile elements for each one of you individually. They're pulling. Now I had them moving this way as a unit, but if I had them pull each other, they would contract, and when they relax, they would expand. So if you were standing this way, you could move the muscle, yes, but the real action is you're pulling each other closer together, which shortens the strand, which pulls the muscle. Demonstrate that one too? Come on, come on. Let me have my myofibrils up here again. Get your arms together, not quite as close this time. Over here. Come on. All right. Myofibril, sarcomere, and I'm the bone. Now, last time we did this, we just kind of went this way. She went that way and pulled us all that way, yes, to make the bone move, and then I pulled them back. Not quite how it all works. How can we make this line shorter to pull me?
Contract.
Contract. Well, what do we mean by contract? Now you don't. You have to stand right there. Okay. Now how are we going to contract? She's the anchor. She's stuck right there. How is she? Okay. You got to pull her too. Okay. So you see what happens now? Even though they're linked together as a myofibril, each one of them has to pull to shorten up. When we relax, relax. Remember before, the strand was pulling us this way because she was moving. But if she's anchored, she can't move. How do we make this situation shorter to pull the bone? They each have to pull, track, right? Are we doing it again? Almost. Okay. Clear as mud on that? No, yes. Bicep. We've done this before, right? Bicep, finger here, finger in the armpit. Sarcomeres are relaxed. But when they contract, they pull, and it brings my arm up, and you can see it's a shorter situation. So it starts this way, we pull this way, we relax. So each one of these little guys has to kind of compress to pull the other one. They're both all doing it. So they pull themselves in. Purpose of a sarcomere, the contractile element, to pull. Remember, this guy's anchored. If I'm anchored, the only thing I can do is pull him toward me. I can't go this way, and I can't go this way. We have to all pull, become shorter. All right, so the sarcomere. Remember that the sarcomere is the contractile element of a muscle fiber. Each one of them contracts to pull the other ones closer to them, and that's how we become shorter, and that's how we move a bone. In order for all of that to happen, in order for us to contract, two things have to be present. Okay? And when you write them down, put a star by them, because these are important concepts. Two things have to be present in order to work. We have to have actin and myosin, which are two proteins that attract each other. I'm actin, this is myosin. I'm over here, she's over there. How would I get closer to her? There has to be an attraction.